Okay, so I mean, just a quick review. I guess the first presentation gives us an overview. I certainly learned a lot of what are the possibilities where analytics can be applied to beyond just enterprise, but into different areas. And I think the second speaker actually even go on into details, looking at charts and visualizations and how how analytics can be used. So to start the ball rolling, is there any first question? I know there are a lot of experts among you. Yeah? Anyone? It's a very good opportunity to ask questions about. Yeah, very good, very good. Thank you.
Hi, thank you. Hi, I'm David from Temasek Poly. And thank you for the sharing, and especially just now you mentioned about the real case study with clean data. So from your experience and the point of view, how to map the sensor data, the PLC data into the real domain? Because just now the sharing actually is very good examples. How this part was being done? Because most of the cases like data scientists may lack of this domain knowledge. Yeah.
Okay, I would say if the person, the data scientist, they have a few electronics background, they know the signals, the step signals, and then that would be much easier sometimes. But I would say the data attributes, most of the time you find they have a dictionary. They have some interpretations. Then basically they give you some clues to understand it directly. But first you need to understand the machine, what it does. Then its component, then it helps you to interpret the signals. Then once you need to develop this feeling, then I think that would be more productive. But in the case, based on the description and based on, you can't figure out, there's always Google search. Yeah. But I would say in the case we have 400 plus attributes, I'm mapping that to different components. If I make an error there, I don't see there's a huge implications, right? But at least you have gotten perhaps 80-90% that correct. But of course, with an expert, you can do much better on that. Right.
Thank you. You also had a question?
Hi, I want to ask about, just now you mentioned about the handling the crane problem in 2 weeks based on data and machine learning, and not really depends heavily on domain knowledge. But then my question is, in that case, how you know if your data quality, the one the crane company throw at you, is good enough to go for machine learning?
In data quality check, we always do that as a first step. The first thing most time we're looking at is are there missing values? Are these values typically out of range? Yeah. So, but in this case, we find today actually for most of the advanced machines, including the crane data we have received, is very good. Yeah. So it's actually not a big problem. Yeah.
Okay. You look like you have got a question, Kelvin.
Just to add, on the previous side, I think actually machine data is one of the best data we've seen, because generally they don't go wrong. Human data can go wrong, but machines are generally better. But sometimes sensors can go wrong. So like if you look at this room, there may be temperature sensors, fire alarm, heat, smoke detectors, all of that. So generally when they're working, you would expect them to be within a certain range. So you could do a few things. One is if it's suddenly 70 degrees Celsius, it means they may be wrong. Whereas there is another sensor which is still showing 25 degrees. So you can do some cross-sensor calibration, validation to then take out the anomalies, and then basically not just take out that data, but then you need to tell the engineers that that sensor may be broken. You need to change that and put a different sensor, because you can get false readings. It's like in your car, sometimes you get, check engine light, it keeps coming, you don't want to ignore it. But sometimes it's just electronic, and then you just need to reset it and everything is fine. So there are ways around making sure the sensor data is ready to be used.
Hi there, my name is Sundi Iyer. I'm a fellow supply chain management consultant from Accenture and EY to my Vulcan AI friends. My question is a very practical one. You gave some great examples of use of AI, both of you guys, both of the teams. Practically in this part of the world, My question is about the cost. So how are we able to justify the very expensive satellite data imaging, or the very expensive, maybe for the mining companies and maybe for the oil and gas companies it's okay, but for an agri company in Kalimantan, Indonesia, where the labor cost, as Manar you mentioned, Dr. Manar you mentioned, these people are not very educated also. So the cost is a very important element. So my question really is, how do companies justify the investment in data capture, in cost expensive analytics, talent, all of that gamut of it in very practical kinds of ways. So long question, but I think your answers would be fantastic.
Yeah, because we were in consulting for a long time. So these are the kind of questions we used to always get, that, oh, you guys are expensive. I don't know if it's going to work. AI, does it work? My labor is really cheap in Indonesia. Why do I need to do this? So I think there was a period where people treated AI more as a R&D experiment. And then he said, okay, you do something in 6 weeks, 8 weeks, you show that it works. But the good thing is, it's very important to select the right use case. So even with clients, we basically identified like 30, 40 ideas. Some of them are really cool and cutting edge, but may not move the needle that much in terms of the output. So the use cases which you see, actually they went through a very rigorous process with the head of finance, with the business owners, and you literally, I mean, for AI guys, that's not a very pleasant discussion. You just want to get started. You just want to say, oh, give us the data, we'll show you something. But you're forced to have that business conversation. So we actually had to make, so based on the pilots, we basically said, okay, the example around replanting, like how many young trees actually die, right? So they said, oh, okay, let's look at data. 5 to 10% actually die in that. Then the same math we did, right? So that if each tree is $25,000, and if 5 to 10% are dying, and of course your workers may fix a few of them, but even if you can save 1% extra, that X million dollars. So when we paint that picture to them, then they said, okay, I think we're ready for that investment. But the other thing which we also need to do is close the loop in terms of the action taken. Because sometimes what happens is the AI gives an output, and then you're very happy that, oh, we found something. But then if you're not closing the loop in terms of, oh, the person actually takes an action and it's fixed, then there's a business case. So the other thing which we do is, when we first fly the satellites, we get the problem areas, take the action, then we fly the satellite again 3 months later on the same location to see whether there's an action taken or not. So then the same typical false positives type of analysis, that how many times were we able to predict some problem and there was really a problem and it was fixed, then it becomes part of the reporting process, that this is the money that has been generated by the AI because it discovered new things. So I think that is really important, because as economic uncertainty around the world, people want a business case, people want returns. I think in the earlier days, banking, telco is very easy, because the focus used to be on selling more. So the minute you run a campaign, you get X% more, money has already been made. But when we think about predictive asset maintenance, actually a perfect system is where machines don't fail. So if machines are not failing, how do you actually build a business case? It's a very tough one to actually convince, because you will say, like cranes, they will say, oh, our cranes are actually pretty good. Like one will fail once a year. So if one is failing once a year, and then if you do AI and you've prevented it, then how you can actually never say that you prevented it because it was working, right? So it's difficult. Some use cases are easier to convince, some are a little bit more. But yeah, sometimes what we do is, a good, strong use case generates a lot of money, and that money can then be invested into some other use cases.
I would say, yeah, indeed, it's very much depends on the use cases. You would say, many cases, if you have not been using AI, you use a rudimentary way of managing certain logics. You just apply AI method, maybe a simple decision tree. You find that you get a performance improvement. But in some other cases, we would say is very important. The performance is really important. For example, in the commodity price forecasting, if let's say the procurement need to make a decision based on your forecast, they have to have very good confidence about the accuracy, about your forecast accuracy. They want you to have very strict validations. You can push the model to the limit. to give you the best accuracy. Then, to a certain level, they can start consider to use it. Otherwise, they will prefer to use their old ways of doing that. Basically means I don't take the market forecast into my decisions, right? So I would say it depends on the cases.
I think just to add the specific example of satellite images, as technology changes, alternatives become cheaper. So if you think about 2 years back or even now, almost every agri company flies UAVs, right, to actually monitor what's happening. The cost of flying a UAV is about $1.20 per hectare. The cost of satellite images 20 cents, 30 cents per hectare, right? So I think as satellite images are becoming cheaper, they're actually becoming even more cheaper than flying UAVs and drones. Plus, you can actually cover the entire swath in one go, right? There are other challenges, but there's definitely cost improvement from that standpoint. I think the other point, which is quite interesting is when we were having this conversation, there was a vendor who was saying, I could put one sensor inside the tree and that would tell you exactly what's happening in the tree, right? And they said that sensor costs $5. Now imagine you have 1 million trees, right? Or 5 million trees, 10 million trees, you scale it up, it's not a value proposition that makes sense. And that's exactly why remote sensing is an area that is a focus, because you can cover the entire area at a cheaper cost, say where the problems are, and then you can actually go there and solve the problem on the ground, rather than actually saying I'll have a mesh of sensors everywhere, because it doesn't make sense from a cost perspective, right?
All right, thank you. Any last questions? Maybe just one more last question. Yeah, okay.
Hi, thanks for the sharing. Right, very interestingly tonight, all the use cases are very industrial. Fortunately, there isn't anything to do with too much human facial recognition, that kind of stuff. So I'm just going to ask, right, okay, in this part of the world so far, how big is the topic on bias in AI model training, and at the same time, right, on the explainability of AI? Is it coming out as something that you all come across in the industry?
Yeah, I think not so much in the industrial side, but if you look at, let's say, security, right, whether it's Singapore or other parts of the world, bias becomes an important factor, right? So if I look at, who is likely to smuggle things in, right? You can have an AI model that looks at that particular exporter or importer, where is it shipping from, what is coming in. So an AI model can be quite accurate in terms of predicting, but is it then profiling a specific set of people, so you go after them more often, right? Same thing from a policing, drug enforcement standpoint, right? A lot of data exists maybe for people who consume drugs but are poorer, right? And then if you train the model based on that, you end up catching the same people again and again. And there are recreational users, in Singapore's context, living in condos and so on, whom the model would never predict, because it's only learning from people who are, consuming drugs in a different environment, right? So those are biases that obviously come in. I think those are not very easy to solve, right? Because you are looking at that data and learning from it. The only aspect that helped us in a kind of security kind of setting is to combine that with an anomaly detection model, right? So I may not be learning from it, but I could detect it, right? So we also used adversarial networks in some cases to, fake certificates. People generate fake certificates to, to enter country as a visa and so on. So again, how do you go beyond the typical universities that you've always seen, or this university in India or this university in China? How do you go beyond that? We basically use adversarial networks to generate data that you have not seen and then learn from that.
Anything else to add? No? Yeah.
The explainability part is quite important.
Yeah.
And I mean, even on the industrial side, you're basically dealing with engineers. So black box is not an option. You're not going to say, it's going to fail tomorrow. They want to know why, and you need to convince, because fixing it is expensive. And then sometimes it backfires, right? Because basically the AI discovers something which is a physics equation. So I think we had an example. I think some data scientists got very excited and said, oh, I found that when temperature goes up, pressure also is going up. And then basically that's Boyle's law, I think. So you didn't need AI to figure that out. So I think before you jump up and down and say you found something, you basically need to revisit the physics fundamentals. And that's why it's important to work with engineers, because they can tell you, hey, I already know this. This is physics, right? So you don't need AI for that, right? On that happy note, I'll stop.
Any last?
Maybe I would just say, just give you a simple example is sometimes if we detect anomalies from the signals, then we found some anomalies is indeed due to the machine functional failures, early signs, very important. But other times could be due to the sensor they have fault, right? Maybe it's just a minor problem. You don't have to stop the machines. With explainability to say why this has been detected as an anomaly, this can be easily resolved. To say this is a sensor fault, that's a functional failure. Then, but if you don't have that, you can't even make that decision. Basically, you are just dealing with a bunch of signals generated. Human has no clue how to act upon them. Yeah, very important.
Thank you very much. So with that note, let's give another round of applause to our speakers. Thank you for their time. Yeah. Okay.